Hello, everybody, and welcome to today's session, where we'll be talking about the identification of fraudulent and unregulated mobile devices. My name is John Leonard, and I look after the product management aspect of the Affiliates Device Intelligence portfolio. A couple of housekeeping points. If you do have any questions, you can record them via the dialogue on your screen, and we'll address those at the end. So thank you very much for joining. We hope you enjoyed the session. With that, I'll hand you over to Ronan Kremen to take you through some background.
Thanks, John. Hi there. My name is Ronan Kremen. I lead the engineering initiatives at Affiliates. So I'll start off today by giving you a quick backdrop on who we are and what we do. This will help contextualize the rest of the presentation for you. So I'm going to move on one slide. Great. So John and I are speaking to you today from a company called Affiliates Technologies. We are mobile and web specialists. We have a portfolio of device intelligence products consisting of 3 different product lines. We're headquartered in Dublin, Ireland. The products that we make available to the market are, first of all, DeviceAssure. This is the product that we will be talking to you today about. And DeviceAssure is an authenticity verification product. In other words, it lets you verify the authenticity of a device that you're interacting with remotely. And just to be more specific about what that means that we can tell you if the claims of identity that a device is making are true, if a device really is what it says it is. So this is just one of our products. The other two are Device Atlas and Device Map. Device Atlas is a device identification product for the web and app ecosystems. And briefly, this lets you identify the nature of a device with which you're interacting with. So if you are a content provider on the internet and you have an interaction with a device, Device Atlas will tell you the type and nature of that device and all of its properties. We have a database of 75,000 different mobile devices, essentially every phone, tablet, set-top box, and so on sold around the world. This is updated daily with about 50 new devices added each day. And by knowing the device that you're interacting with, this turns a blind transaction into one, or blind interaction into one with which you have much more information to work with. You can use that information to better serve the user, better understand the user, or better target the user. So Device Atlas lets you add interesting metadata to an interaction online in a web or app ecosystem. Device Map is a companion product. It's similar to Device Atlas, except that it's repurposed to work in a mobile operator environment. And this is a product that we make available in conjunction with the GSMA. So that's Device Map. And just a sense of our broader organization, Affiliates Technologies is part of Affiliates Inc., which is a broader company. Affiliates Inc. is an internet infrastructure company. We run a good proportion of the internet's DNS system. We operate a few hundred top-level domains, including .org and .info. And in order to do that, we have built up a lot of expertise in scalability. We are operating truly at internet scale. Availability, we've had no downtime at all since in about 20 years. And of course, security. So we've built up a lot of expertise in these areas over the years. In terms of physical reach, we are truly global in that sense also. We have offices in the United States, Canada, Ireland, India, China, and Australia. So that gives you an overview of the company. I'm going to move on now to talk about some of our customers. First of all, these are our device intelligence customers. We serve 6 of the top 6 mobile operators in the United States. We have over 20% of the Fortune 100 as direct customers and many more as indirect customers. And this all leads to traffic in the order of trillions of requests per month. And that's just the traffic that we know about. So the use cases for all of this information tend to fall into 3 areas. They are analytics, optimization, and targeting. And to give you a sense of the customers, in the analytics space, we serve Adobe, Nielsen, and SES, and others. In the media space, Netflix, Disney, and the Financial Times are customers. In the ad tech space, Verizon Media, Xandr, and the Trade Desk are all customers. And in retail, Amazon, PayPal, and Walmart are all customers. And there are many more apart from that. This is just a brief overview. So these customers use us for analytics, optimization, and targeting. And another way to understand who we are and what we do is to look at our partnerships and affiliations. I mentioned in the first slide that we are partners with the GSMA. We've had a partnership for over 5 years at this point, and this is partially around the device map offering, but we work with them in other ways also. We are also partners with the Mobile and Wireless Forum. That is a trade association of mobile device manufacturers, including essentially all the major manufacturers worldwide. We work with them on counterfeit devices. And in terms of actual memberships, we are members of the GSMA, as I mentioned. We work with the Interactive Advertising Bureau on the real-time bidding standard for advertising online. We are also active members of the ITU. This engagement started with them as invited experts. We were invited to contribute on the topic of stolen and counterfeit devices. That has since become a full-blown membership, and we are now active members of the Study Group 11, where we work on standards and advice around this topic. Over the years, we've picked up quite a few awards. The most recent one was for DeviceAssure. Just last year, we won the IHS Market Innovation Award in 2019. So that gives you a rough sense of who we are and who we serve. I'll pass it back to John now to give you a sense of the industry problem.
Thanks, Ronan. So I'll talk a little bit about the market problem and where it leads us. So if you think about the world of connected devices, it's an enormously fertile world for criminal activity as well as perfectly normal usage. And I think a key goal of a bad actor in general is to completely hide their existence. That's the perfect world if they can hide their existence entirely. Now, this isn't always possible. But a second best, if unable to completely hide their existence, is to masquerade as something entirely innocent. And this is really a key aspect of what we're doing today, is identifying cases where actors or visitors or users of content are seeking to mask their identity. So to look at some examples of identity concealment, if you think of the landscape as 3 separate ecosystems, so a smartphone, for example, can simultaneously exist in 3 ecosystems. It connects to the web, it makes cellular connections to the mobile network, and it's connected to the native app ecosystem via installed apps. So different devices have different connections in different ecosystems. So for example, an IoT device might only exist in the mobile network perspective. A Wi-Fi only device, such as, for example, a media player, might just exist in the web and app ecosystem. But the examples from an identity concealment point of view, in the mobile network, modified IMEIs are how the concealment takes place. So the TAC is the first 8 digits of the IMEI, and the TAC identifies the model, the make and model of the device. If that is changed, the device appears to be something different. In the web landscape, the browser identifies itself to a web server via HTTP headers, which include a user agent string. If those are modified, again, it appears to the web server to be a different class of device. And finally, native apps. Within the native app environment, the OS identifies itself to the application via a make and model string, for example. But what we see is custom ROMs are used to modify how the device portrays itself in the app ecosystem. So there are different ways in which a device may seek to conceal itself according to the ecosystem in which it's operating. So what are the motivations for changing of identity? So if we look at the IMEI changing aspect, there's a range of different motivations to do this. So first of all, counterfeit and non-standard devices. So typically these are very low-cost devices produced to low specifications, but sometimes seeking to emulate high-value devices. Now, typically these devices will not have a valid IMEI. They are very low margin, so any cost is something to be removed. So these devices will typically either have an invalid TAC or they will use a valid TAC or IMEI from an existing device. So another category is laundered stolen devices. If your cell phone is stolen, if you want to claim insurance on it, you're required to demonstrate that you have reported it stolen to law enforcement. And in that process, you have to provide the IMEI so that IMEI can then be registered in a central database maintained by the GSMA. So network operators can deny service to that stolen device. Now, one of the challenges is that stolen device, if one may use the term supply chain or value chain for that activity, the IMEI can be changed to either an invalid one or shall we say, an innocent one, as a way of laundering the device and allowing it to continue to be used on networks. Network features access, what this refers to is really, by changing the IMEI, you can affect how it's seen and handled by the operator network. So one example is to change the IMEI to that of an IoT device, which could mean the device qualifies for different data rates or different subscription options. But also different features can become available to different devices as well. So by changing the IMEI, one can affect the features available to a device from the network. Registration bypass refers to the scenario. So in some countries, devices have to be registered. The IMEI is recorded in a government-run database to determine whether taxes are paid, whether the device is legitimate, etc. So by modifying the IMEI to a valid or another alternative device that's already been registered, service can be continued. And finally, privacy is another occasional motivation for people to change their IMEI. Now, changing the IMEI isn't necessarily straightforward. On some devices, it's extremely difficult or nearly impossible, and Sony and Apple are examples of this. But in others, it's extremely easy. So if you have a MediaTek chipset in your device, you can actually change the IMEI via a key sequence via the telephony keypad. So extremely easy to change the IMEI on a MediaTek chipset powered device. And if you are looking at the Google Play Store, and you can look up IMEI Changer, for example, and you'll find many apps which facilitate this. In some cases, it's necessary to root the device, but in others it isn't. It depends on the device itself and the manufacturer. So those are some of the motivations as to why an IMEI might be changed. In the web, so the user agent string is typically what is modified, or it could be other aspects of the HTTP headers. Bots and crawlers will often seek to mask their existence. So there are good bots and bad bots. Most good bots will typically identify themselves correctly and advertise their existence, so they can be managed by web servers, but many bots do not. So the ability to access content designed for different devices, there are many examples of this. Many smartphones actually support this. The browser may actually have an option to set to download the full desktop version of a website. And this requires modification of the user agent string by the device in order to retrieve full content. And this pools the web server into serving the full desktop web page, full images, etc. So that's a simple example. There are many like this. By modifying how the device appears to a service, it can affect the content delivered. Ad fraud is another example. This is a significant proportion of ad traffic, whereby by modifying user agent string, the value of the traffic can be modified. So low value traffic could be made to appear as higher value traffic simply by changing the devices that appears to be from. And finally, privacy, again, is a motivation for changing the UA string. So this is relatively straightforward to do in many browsers. User agent switchers are available as browser add-ons for many browsers. Again, it comes very much down to the browser capabilities as to what it supports here. So if we talk about some general fraud examples, so these are examples of fraud where the concealment of the changes of identity typically accompany it. So consumer fraud via the purchase of cloned devices. So whether these are outright counterfeits or simply non-standard devices sold at low price, it's very easy to purchase a $50 device online, which resembles very closely a high-end, potentially $1,000 device. And these are available at $50 is very straightforward, and these are shipped in using reputable shipping agents. So it's a very simple way to obtain a apparently quality device at low cost. Now, there's two classes of fraud in this area. Some consumers may unwittingly purchase a fake device, or they may actually know they may deliberately set out to acquire one. But for example, it's quite easy via classified ads to find examples where a high-end device is being sold at, for example, half price because it's an unwanted gift, for example. So an $800 device might be marked down to $400, but the true value might actually be only $50. So a consumer might easily be taken in by such an ad. But another example, a teenager might choose to buy a $50 device online simply to get an apparently more premium device at a low cost. Now, malware distribution is another area where concealment is really part of the package. So what we've identified ourselves is that non-standard and counterfeit devices are vehicles for malware, and a wide range of malware types, such as keyloggers, ransomware distributors, rootkits, etc. Now, we conjecture that this is part of the business model for the non-authentic device, because these devices are selling at such a low price that the margins must be extremely thin. So by acting as conduits for malware, they improve their business model. In effect, they're selling the identities and the data of the people who purchase them. So ad fraud is another area, as I've mentioned. It's a way of converting low-value traffic into high-value traffic. Content redistribution. If you're in the business of, say, streaming video content, and you're serving a subscriber who appears to be using a smartphone or a set-top box, but in fact, behind the scenes, it's actually a very large 16-core server, there'd be good reason to question what was that server doing with your content in the background. And it's quite possible that it's being remonetized and redistributed to other parties. Insurance fraud. With the easy availability of a $50 device, which visually and physically is very much like a $1,000 device, it's very tempting to insure this at a value far above its true value. So it is a pathway to fraud. And finally, excise duties and revenue avoidance within country. I'll come to this a little further on, but different countries have different policies in this area. But sales tax on a $1,000 device looks very different to sales tax on a $50 device. And that's if it even comes in through legitimate channels at all. So the challenge in the industry, quite simply, how do you verify that a device is what it claims to be? And that's the question we seek to answer today. To answer this question, we need to ask another question, which is, what are the symptoms of modified or incorrect identifiers? And this is actually very simple. So in the case of IMEIs, you get duplicate IMEIs in the network. Now, in other examples, you get unaligned identifiers. So the identifiers of the device no longer match. So if a device is present in 3 ecosystems, you expect 3 identifiers. They should align. If they don't, that's a symptom of a modification in some form. And finally, the identifiers are expected to match the hardware. So if the identifiers don't match the hardware, there's a problem, and that's a clear symptom of a device concealing its true identity. So DeviceAssure performs this task. It analyzes the device and its identifiers, and thus What it delivers is certainty about the authenticity of the device, and this allows appropriate handling of the user. And the key advantage is this works remotely, immediately, silently, if desired. And finally, it is global in coverage and no PII is required. So I'll pass over to Ronan now to talk in more depth about the solution itself.
Thanks, John. So we'll look a little bit more in detail as to how this works at a physical level. So the way to think about this is if you break down a smartphone, it can be thought of as consisting of three distinct layers. Starting at the bottom on the picture on the right, there's the hardware, that's the CPU, the GPU, the screen, the camera, the battery, the sensors, and all the physical bits that make up a phone. Running on top of that physical hardware is the operating system. Nowadays, that's typically iOS or Android. And then on top of that, again, you have the apps that we're familiar with, like web browsers, social media apps, and so on. So there are three distinct layers in a modern phone. But each of these layers makes claims of identity. So if you consider each layer in turn, at the apps level, any app that interacts with the network emits an ID of some form. So in the case of the browser, John mentioned there's a user agent string, but any app that interacts with the server online emits an ID of some form. The operating system sitting underneath the apps also has a claim of identity in the form of a manufacturer model, which can be programmatically queried. So any app can ask the operating system, what am I running on? Finally, on the underlying hardware that underpins everything, there are multiple claims of identity that can be programmatically tested. The type approval code is the GSMA issued device model identifier at a cellular level. There's a MAC address for the Bluetooth chip and for the Wi-Fi chip, and there are other identities burned into the various components that underpin the device. So each layer of the device makes identity claims distinct to that layer. If you combine that with the fact that a modern smartphone is really a full-blown computer, modern phones have thousands upon thousands of properties and behaviors that can be probed. So you can do this really quickly and silently in the background on a modern smartphone. So if you take all of this together, and if you recall from the start of the webinar, we mentioned that Device Atlas has referenced authoritative data on essentially every connected device that's sold worldwide. So we have authoritative data on 75,000 different device models. So we know what a device should be given its claims of identity. So as John mentioned, when presented with a device under test, we can check two things. We can, first of all, check that all of the claims of identity align. In other words, is the hardware and the operating system and the apps running on top of the operating system, are they all making claims of identity that are consistent with each other? But secondly, we can also test the device that we are actually running on. So when DeviceAssure runs on a device, it can inspect the properties of that device, the physical properties and behaviors, and ensure that those measured properties are consistent with the claims being made. So that's the essence of the solution here. But to put it more concretely, it helps to imagine how this might actually be deployed. So DeviceAssure is shipped in the form of a library. So this library can be embedded in either an app or a website, or indeed an SDK that gets embedded in further apps. So we ship a small library that can be embedded in any mobile app or any website. So typically that app or website is then run on a smartphone, or the page is opened on a smartphone. And at that point, the library can inspect the physical properties and behaviors of the device. It assembles this information together and sends it to the DeviceAssure backend service. So at that point, the information received is analyzed and a result is sent back to the device in question that says whether the device is authentic or not. Now, the app or the website can decide whether or not to surface that result to the user, and it's completely up to our customer as to what to do at that point. the result of that determination can also be sent to a server rather than the app or the website itself. So if you put all this together in about a couple of seconds, from loading the page or running the app, DeviceAssure has given a determination of whether that device is authentic or not. So just a couple of seconds, and the user need not know what's going on. The conventional functionality of the app or the website remains untouched. This all happens in the background in a couple of seconds. So it might seem like the result of this check is a simple binary answer, whether the device is authentic or not, but actually it turns out there are quite a few shades of gray. So I'll turn it over back to John to talk about the different result types.
Thanks, Ronan. Yes, we were actually surprised ourselves to discover the diversity of ways in which a device can masquerade. So we had to develop a taxonomy to provide a meaningful breakdown and an effective classification of how devices appear. So I'll run through them to give a broad understanding. So first of all, the simplest one is authentic. And when we return an authentic result, that means that the device capabilities are fully aligned with all of the device identity claims. In other words, everything is consistent and as expected. So, but at the opposite end of the spectrum, non-authentic, this is where the device is explicitly different to what it's claiming to be. So at a technical level, it is deceptive. It is making a claim to be one thing, but it simply isn't that. So it's infringing trademarks at a technical layer. Now, we can't say for sure what's written on the device, but at a technical layer, there's deception going on. Now, a step up from that, a device may have valid hardware, but an invalid TAC. So if that arises, we identify the device as non-compliant, which means that from a regulatory perspective, it isn't compliant due to the invalid TAC. And as a result, this may, depending on the use case, this may be decided to be handled differently. However, the hardware itself is fine in this scenario. Another level is what we identify as inconsistent, which means that the hardware is aligned with at least one of the identifiers, but the identifiers themselves are not consistent with each other. In other words, it's making different claims at different levels. And this is an indication that it may be compromised or have been tampered with at some level, although the hardware itself is probably fine. And finally, indeterminate classification is where we aren't able to interrogate the hardware, or the identifiers are not recognizable. So there would be major question marks typically in an indeterminate scenario. Now, DeviceAssure doesn't just provide the classification, it also provides the reason, what we call the result reason, the reason for the classification given. So it provides what the differences are or what the identifiers were, what mismatches occurred, what the hardware profile looks like, etc. So it provides quite a comprehensive set of information back about the device under test. Now, in addition to these broad classifications, there's a range of additional results possible, which can supplement the primary classification. So an emulator in the app context is where a device appears as server hardware while perhaps claiming to be a mobile device. A proxy in the web context is identified. This is specifically where a proxy prevents the test running on the actual end device because a server in the interim, or a server in the process is the one where the test is actually being run. So this is specific to the web library. Bots similarly are related to the web library where the user agent string is making one claim, but the hardware may be a substantial server instead of a connected device. Rooted devices. The DeviceAssure identifies rooted devices, but it's not a core function. If it's clearly a rooted device, it will flag that, but it's not the core goal to identify all rooted devices necessarily. Some root methods can be extremely well concealed, and it's not a core goal to identify all. So custom ROMs are also identified where they arise. So I'll talk a little bit about implementation at a high level of how it can be presented externally. So there are two main entry points. One is to visit an enabled web page with the device to be examined, and the second is to install an enabled app. So the app can be enabled either because it's got an enabled SDK embedded in it. For example, a monetization SDK or an analytics SDK could carry the DeviceAssure functionality. And an example on the right, this is a web page belonging to the MWF, the Mobile and Wireless Forum. They have a website called Spot a Fake Phone, and DeviceAssure is embedded within a page there, which allows verification of a device. It's also a rich source of information and context about counterfeit phones in general. So example pathways by which one might drive the functionality to the device. One example would be to send a link via an SMS. And this could include an offer or an incentive. And the link could be for the consumer to click on, but it's also possible to automate the clicking on the link so that a silent visit to an enabled web page happens in the background. Another option is to send a QR code, which points to a web page with the capability embedded. And finally, simply to bundle it into an app offering content or services. The DeviceAssure capability can run in the background. So some important benefits. First of all, there's no dependency on the registration of the consumer device. So this is a solution that can run in-country on devices already in circulation. There's no dependency at stopping them at the border and examining them. It's a test that can be run anytime in any targeted area or on targeted devices. So there's no PII required. I mentioned the IMEI a few times. Although the IMEI is PII, DeviceAssure does not require the IMEI. It only requires the TAC. And the TAC is the first 8 digits of the IMEI, and it has no personal link. It purely identifies the make and model. Now, the transparency on the data aspect, DeviceAssure can be set up in what we term a server-to-server manner, whereby the whole communication happens via our customer servers, so they have full transparency on everything going back and forth. So it's very straightforward to implement, just the embedding of a library, and the result can be immediately actioned. It's usable straight away. Depending on the use case, the appropriate action can be taken. And I'll come to the use cases shortly. So, but the recommended phasing, typically we'd recommend setting up to run a measurement first, and that gives information and insights into how does the landscape look, what is the distribution and nature of devices within the target group. And that allows formulation of policy. And then once that is established, one can scale up to implement and enforce policy. So if we come to use cases in different verticals, device insurance is one example. If a consumer is seeking to insure a mobile device, the risk is that the device is a clone or compromised device from a secondary market. So the goal is to validate a number of things about the device. Firstly, does it exist? Second, does it work? And thirdly, is it authentic? Now, the way to establish these things is to require that the device to be insured visits an enabled web page or installs a native app to run the validation. And if the device returns anything other than authentic, then extreme caution would be needed about providing insurance, or it may affect how or what one chooses to offer that consumer. With duplicate IMEI resolution, I mentioned earlier that one of the manifestations of non-standard or counterfeit devices is duplicate IMEIs in the network. Now, this is actually quite a widespread problem to our understanding. It obviously varies massively with geographic region. But if you have, say, 10,000 identical IMEIs on a network, DeviceAssure allows the identification of which of those IMEIs at least match the hardware of the device on which they are embedded. So you can filter down very quickly. You can filter down the 10,000 to say, well, of these 10,000, X of them don't match the hardware, and therefore steps can be taken to communicate with those separately, those subscribers, and according to the policy required. So it's a way of scaling the problem down very materially to bring it under control. In a consumer banking scenario, we mentioned about malware. If there's a risk of malware, you don't want a consumer engaging with the banking service because their details will be compromised. So in the scenario that the consumer installs a retail banking app, the first check that should be done before they even enter their credentials should be to validate, is the device authentic? Is it safe to run this app? And then if it's authentic, then yes, that can proceed. But if there's any question mark about the device authenticity, the app shouldn't even ask for the login details because there's a risk with the keylogger, for example, of compromising the user account. Similarly, in an enterprise security scenario, typically enterprises will invest in services of enterprise mobility management solutions or mobile device management solutions. But what we've established is these devices do not actually verify the authenticity of the device. What they'll do is they'll check for patches, check for security updates, check for known risky apps. They'll just check that everything's patched and up to date. And they do run a range of checks, but every single mainstream solution we've checked doesn't actually verify the authenticity of the device. And this leaves a gap because what we've seen is that malware can be buried very deep in a non-standard or counterfeit device, down at a hardware or firmware level, where security solutions don't have visibility of them. So checking authenticity is a good way to reduce the risk and improve security posture. So finally, at a consumer protection level and maybe at a regulatory level, so the problem here is that the non-standard devices enter the country one by one in single packages to a great extent. It's no longer really a problem of whole shipments whole containers in a shipment, which can be managed at the border more easily. When individual packages come in one by one and often mislabeled, so many of the devices we've received, non-standard devices, have typically been mislabeled with an incorrect value placed on them. So typically they come in marked as an MP3 player for a value of $25. So in this way, they very easily pass or evade customs scrutiny. So the goal is really to measure or identify what is the scale of use and distribution of such devices within the country. And the pathway to solve this, therefore, is the use of DeviceAssure in existing services or offerings provided to the consumer. And for example, we see some regulators offer services to consumers to check IMEIs. So if they're purchasing a second-hand phone, they can check that it's not stolen. A range of services like this. And DeviceAssure fits in very cleanly in these kind of contexts to provide an extra protection. Is the device authentic? So the outcome here, you get a reduction in defrauded consumers, but also improved regulatory compliance and strengthened excise revenue. And we have heard of cases via the ITU, of cases where very material sums of money, in fact, we heard of a case of $1.4 billion improved government revenue in a single year after establishing a registration process. And by itself, that is quite a leaky process, but it demonstrates that there are very material sums at risk here. So to sum up, DeviceAssure is a very straightforward solution to roll out. It does enable measurement and control of the problem by identifying non-standard device access and resources. It is backed up by a really robust and global solution, Device Atlas, and it does provide global coverage. And it's not just smartphones. We actually started identifying counterfeit set-top boxes a few months ago. So it's global in more than one sense. Finally, it is transparent, robust, and scalable. So I'd like to ask if anybody has any questions, please do register them via the webinar interface, and we'll work through them now. Thank you very much for your attention.
I can take the first question, John. Thank you. So the first question I see in the queue from the attendees is, are there any prerequisites from my tech stack point of view to install this solution? So the really quick answer to that is no, that whether you're integrating DeviceAssure from a web point of view or a mobile app point of view, we have no particular prerequisites in terms of languages or anything. So there should be no surprises there whatsoever in terms of installation.
Thanks, Ronan. There's a question, is there a risk that refurbished devices will be considered non-authentic? This is a very good question. I mentioned earlier in the classifications, we do provide an authentic classification, but within the authentic classification, there are actually 3 sub-classifications. So there's the original device specifications from the manufacturer, but also, as you're probably aware, devices are continually updated over time. So manufacturers will have a cost reduction program whereby over the course of several years, they will steadily reduce the cost in order to maintain margins. So the components and makeup of the device will change over time, even though it's the same model. So you've got the original device, you've got variations on the device, and finally you've got refurbished devices. So these are also classified as authentic. So as long as the hardware matches one of the original valid variants, in other words, as long as there's full hardware match, then the device will be identified as authentic.
Thanks, John. The next one I'm seeing is, how difficult or complex is the implementation process? So the answer to this depends a little. There are 2 main forms of integration for DeviceAssure. So on the website, the integration takes the form of merely linking a JavaScript library into your website. And that's as easy as linking any other JavaScript library. Merely adding it to the website enables the capability within the page. On the app side, there are more steps because we require that our module is compiled into the app. But to give you a sense of how easy or difficult that is, we tried adding DeviceAssure to the open source Firefox browser, and within 30 minutes we had it integrated. So the actual compilation step is very straightforward. Where much of the work resides is actually deciding on what to do with the result that DeviceAssure gives you. So typically customers will have to decide, given a determination of authentic or not, how do you then respond? Do you flag to the user? Do you do nothing? Do you log it? In the banking app example that John mentioned, the right outcome might be to shut down the app if the device on which it's running looks to be counterfeit, because it's not safe for the user nor for the content provider or for the bank. So the bulk of the implementation difficulty tends to be deciding what to do. So it's a workflow consideration rather than a technical difficulty as such.
Thanks, Ronan. There's another question asked, which is, why is the analysis done on TAC basis, not full IMEI basis? And the reason for this is the TAC is allocated to manufacturers for use on the device. And it does represent the hardware of the device. So the TAC is a representation of the full hardware of the device. The only exception being in the case, for example, with Apple, where you can have different storage capacities under the same TAC. But that is actually an anomaly in the TAC issuing model. So the TAC is actually sufficient. So we choose to focus on the TAC for 2 reasons. Firstly, because it is sufficient in pretty much all cases to identify the hardware. But secondly, also because it explicitly avoids a PII risk. And with increased sensitivity to privacy and PII risk globally, it is a stance we've always taken that device intelligence should be focused on being about the device and not the user.
The next question I'm seeing in the queue is, do you have any examples of DeviceAssure identifying fraudulent devices, including the threats prevented? So, good question. Over the years in developing the solution, we've acquired a lot of different handsets, counterfeit and of mixed provenance. And in doing so, we've seen lots of different types of threats. So rather than we're mobile device experts rather than security experts, so we sought the help of a New York-based security company called Trail of Bits and sent them a few counterfeit devices to examine. And their report on the matter was 17 pages long. In other words, they found 17 pages worth of vulnerabilities and malware on these devices. And these, I mean, John mentioned some, but they really ran the gamut. There was every type of malware that you've ever heard of pre-installed and unremovable on these devices. And in addition to keyloggers and more routine things, there were DDoS agents and also plain vulnerabilities. The operating systems of these devices tend to be faked. So they will say they're Android 10 or 11, but in fact will be Android 4.4, which has all its own issues. So if you want to read more about that, the report is on our blog on DeviceAssure.com, or you can go to the Trail of Bits website at trailofbits.com.
Thanks, Ronan. There's a question to confirm if the end user's device, if the end user's consent is needed. This is a very good question, but this is very much subject to local laws and norms. So we provide a solution, but we don't identify how it necessarily has to be packaged. So we would generally recommend that there's transparency to the end user, but that may or may not be actually necessary, because the end user themselves, in some cases, they're accepting some terms and conditions, and you might wish to say in the terms and conditions, we will verify your device suitability for the service, for access to the service. But really, it depends a lot on the use case and the local privacy regulations in the country as to whether end user consent is needed to verify their device. So it's really a case-by-case basis. I hope that helps answer the question.
Thanks, John. The last question I'm seeing on the technical side is, can you share details about the latency? So the quick answer to this is it depends, but a more useful answer is to give a kind of a range. So the inspection of the device tends to take less than about a second or so. The information gathered in that inspection has to be sent to the DeviceAssure backend service, but the size of the payload is really small. It's in the order of a few kilobytes. So typically we would expect an answer back within a couple of seconds. But it's important to note that in the meantime, the operation of the app need not be altered. The user will not know that this is going on unless you choose to inform them. So generally speaking, a few seconds is all it should take. So I think that's the last of the questions I'm seeing on the technical side.
Thanks, Ronan. Somebody's asked, could you please share some details on the pricing? So what I can do there is identify, first, the business model. It's quite simple. It's a fee per lookup, per request and response. And it works on a monthly basis based on the volume of lookups with monthly invoicing. We'd be very happy to engage with you to go into details of how it works and ensure it's a good fit with your own business model. And with that, there's no other questions. I think we can draw this to a close. So thank you very much for attending. And please do contact us via the link there. And any questions, welcome at any time. We'd be very happy to explore your use case and see if there's a fit for your services with DeviceAssure. Thank you very much, and we wish you a good day.
Thanks all.